Hi, I'm Will Martin. As is about to say on the next slide here, I'm going to give you an update on my progress in my class ECE 491. At the end of this demonstration, you're going to see a HDR GUI, that's high dynamic range, that's going to combine three low dynamic range images and composite them into one high dynamic range image. Unfortunately, I'm having problems with the cameras, and that is giving me really poor results. So this first thing that you're going to see in my demo is a run of an image set that was created from different cameras using the exact same algorithm I'm going to show you later on. The purpose of showing you this part is just so that you can see that the algorithm does work given the right inputs. What you see on the screen now is a composite of 5 low dynamic range images of this doll head. You can see it's got pretty good range. A little hard to tell on this video, I'm sure, but there's lots of nice contrast between the dark areas and the light areas. I'm about to bring up some of these smaller images that was used to create the high dynamic range image. Here is the darkest one, and then for comparison purposes, let me put you up the HDR image that we just created. And for comparison, you can look at some of the other images that were used to form it, and hopefully you can see that the high dynamic range image is superior in quality to any of the individual low dynamic range images. But now that you've seen that demonstration, let me move on to showing you what I'm working on currently. One of the main difficulties I faced in trying to complete task 4 is the fact that the 3 cameras I use occupy different physical space and are probably pointed in slightly different directions. So you can't simply combine the images one on top of the other as I did in the doll image. They have to be calibrated beforehand. Without calibration, you can see the problem. If you look over at this filing cabinet, you can see that there's kind of a shadow version on top of another version, and this is because the images are not aligned. The 3 images you see at the top of this figure come from 3 separate cameras, and you can see the problem that I'm facing with the exposure levels. I'm going to get some new cameras in the next couple days here, and I think it's going to solve that problem, significantly improving the output in the bottom panel, which is the HDR combination. You can also see in the video how extraordinarily poor the frame rate is on this process. I think we get a new frame once every 10 seconds or so, and that is mostly due to hardware limitations with the computer I'm working on. The next thing I'm going to show you is the calibration routine that we go through. You see you run this script called camera aligner, and it says calibrate camera 1, yes, 1 for yes, 0, use most recent settings. I'm pressing 1. Now what we're going to do at this point is we're going to use some built-in MATLAB functionality to calibrate the image on the right, which is the reference image, with the image on the left. We're going to do this by selecting tie points. These are points that we know belong to the same physical space in the 2 images, and using a series of these points we can align the image as a whole. This is a fairly time-consuming process, so I'm going to actually fast forward through this part and join up with you again in a moment. The next phase of this process is to export all of the points that we've just generated to the workspace, and then close the point selection window. I've got a variable set up to wait for this to happen within the script. So once this window is closed, it goes on executing the next part of the program. And before you move on, it's going to generate a figure that's going to show you the results of the calibration that you just did. And we're going to see that now. And now we can clearly see that the 2 images have been properly aligned. There's none of that unsightly overlap that we saw at the filing cabinet earlier. We're going to have to go through this same process again with a 3rd camera, and that's going to be the next thing that I show you. I'm going to go through this pretty quickly since you just saw the whole process. a moment ago. Now, something we're going to notice here is that I must have had one of those dots off. The right side of the image is okay aligned, but the left is terrible. Well, it's not terrible, but it's slightly off, which means that the functionality I've built into this aligning script of continue, try again, or exit, we're going to use the try again method, and we're going to go through this process yet again. And in looking at the results from this round, we're still not quite perfect, but I think good enough for the purposes of this demonstration. When I get my set of 4 HD cameras that have a rigid harness, I'll make sure that these are very, very fine-tuned calculations. So now we can see the combination of all 3 of the image after they've been properly aligned, and you can see that they are aligned very well. The HDR combination is in the bottom. This is just a single frame. But as we go through the camera aligner script, this saves all of the variables that are used in the registration process and make it available to the HDR GUI that I was showing you earlier. So as the final portion of this demonstration, I'm going to go ahead and pull that up with our newly determined registration variables, and you can see the final results. So here we can see that all of the objects in the background are very well aligned, the cubicles and the filing cabinet. Of course, there's a different perspective from each of those cameras on my face since it's so much closer than the objects in the background. So my face is not properly aligned. Another reason it's not properly aligned is there is a slight time offset in between the moment that each picture takes a camera. So my face is likely to be in different positions, and that also causes a misalignment. Ideally, for HDR image generation, you would want each individual camera to acquire its image simultaneously with all other cameras. You would probably also want the registration to be locally adaptive so that it could register my face in the foreground as well as the objects in the background. Neither of those topics are going to be ones that I'm going to have time to address before the end of the semester. Once the cameras I'd like to use come in the next couple days and I'm able to build a rigid harness for the 4 of them, I think we should have a beautiful HDR image with nice color balance and a very wide dynamic range. Once I get to that point, I'll do another much shorter demo accompanied by a much more formal and lengthy PowerPoint presentation and a formal final report.